Have you ever imagined standing on the edge of the world, or in front of a towering stone wave that never crashes? From wind-blasted towers in the desert to eerie stone mushrooms growing in frozen landscapes, our planet is filled with bizarre and mind-bending geological wonders that defy explanation. Here are 10 jaw-dropping rock formations and geological wonders on Earth that will leave you in awe. Jutting from golden desert sands like ancient sentinels, the Pinnacles create one of Australia's most bewildering landscapes. Located in Nambung National Park near the coastal town of Cervantes, these limestone pillars vary dramatically in height, some reaching 16 feet or 5 meters tall, while others barely rise above knee height. The raw materials for these curious formations originated approximately 500,000 years ago when shallow seas covered the area, allowing marine organisms to create shells rich in calcium carbonate. Around 25,000 years ago, these shells broke down into lime-rich sands that coastal winds transported inland, creating massive mobile dunes. Recent research of iron nodules within the formations suggests they formed specifically during an extremely wet period about 102,000 years ago. Throughout their history, water played an initial role in sculpting the Pinnacles. Rainwater, containing carbonic acid, effectively dissolved much of the surrounding limestone. As this erosion continued, small depressions and solution pipes gradually enlarged, eventually resulting in the distinctive pinnacle topography. Meanwhile, powerful desert winds gradually stripped away softer materials, exposing the more resistant formations we see today. This persistent erosion revealed cross-bedding patterns within many pinnacles, whereby ancient wind directions from the Jurassic period remain preserved in stone. This extraordinary assemblage of limestone pillars rising from golden sands creates a truly extraterrestrial-looking environment, whereby visitors often describe feeling transported to another planet entirely. Gleaming white terraces cascade down the hillside in Denizli province, Turkey, creating one of Earth's most surreal landscapes. Pamukkale, meaning cotton castle in Turkish, presents visitors with a dazzling spectacle of mineral deposits. It resembles giant cotton balls or frozen waterfalls, earning its place among the world's most unusual geological wonders. The striking white terraces of Pamukkale are formed through a remarkable process of calcium carbonate deposition. This natural wonder began when thermal spring water, supersaturated with dissolved calcium bicarbonate, emerged at the surface. As this mineral-rich water flows downhill and cools, carbon dioxide releases into the atmosphere, shifting the chemical equilibrium. This process forces calcium carbonate to precipitate as a soft gel that eventually crystallizes into solid travertine. The terraces cover approximately 22,000 square feet, or 2,100 square meters, forming a series of steps, ledges and pools that resemble a giant staircase. The sedimentary process continues today, although at varying rates. Each liter of water deposits nearly 500 milligrams of calcium carbonate. The formation's unique appearance varies throughout the day as sunlight interacts with the mineral deposits and water. The terrace's color shifts subtly based on mineral content and sunlight angles, while filled pools create stunning reflective surfaces that enhance the otherworldly visual effect. Unlike the permanent stone sculptures found elsewhere, Iceland's Skaftafell ice formations offer a rare glimpse into nature's fleeting artistry. Located within Vatnajökull National Park in southeastern Iceland, these remarkable glacial structures emerge from the Skaftafellsjökull glacier, an outlet glacier extending from Vatnajökull, Europe's second-largest ice cap. Skaftafellsjökull flows as a living mass of ice, carving its path from the northernmost portion of Öræfajökull glacier down a steep valley. This constant movement creates a dynamic landscape where the glacier essentially sculpts itself. The ice cap's tremendous weight causes the snow to compress into thick ice masses over centuries, forcing all air bubbles out and enlarging ice crystals. This compression process shapes extraordinary features within and around the glacier. The most spectacular of these formations are the ice caves, which develop when glacial meltwater carves out tunnels and chambers within the ice. These caves form differently each year, making every winter season's discoveries entirely unique. The most striking characteristic of Skaftafell's ice is its remarkable colour palette. The compressed glacier ice often displays an enchanting blue hue, resembling glittering sapphires and diamond-like cathedrals. This occurs because the dense, compressed ice absorbs all colours of the light spectrum except blue. Finally, climate change significantly impacts these formations. Rising global temperatures accelerate glacial retreat, altering the timing and volume of meltwater discharge. This threatens not only the accessibility of these unique formations, but their very existence, making each visit to Skaftafell's ice world increasingly precious. Beneath the rolling hills of New Zealand's North Island lies a subterranean wonder, where living creatures, not geological processes, create the spectacle. The Waitomo Glowworm caves offer visitors a uniquely organic, weird rock formation experience, where biological light transforms limestone caverns into a mesmerizing otherworldly realm. The cave's star attractions aren't actually worms at all, but the larvae of a fungus gnat species called Arachnocampa luminosa, found exclusively in New Zealand. These remarkable creatures produce blue-green light through a specialized biochemical reaction, involving a distinct luciferase enzyme that differs from those found in fireflies. The limestone formations in Waitomo began developing approximately 30 million years ago, when the region remained submerged beneath an ancient ocean. The limestone primarily consists of fossilized corals, seashells, fish skeletons, and various small marine organisms compressed over millions of years. The culminating experience in Waitomo occurs during a boat ride through the Glowworm Grotto along the underground Waitomo River. In near silence, visitors float beneath thousands of tiny blue-green lights resembling a living galaxy. This starry effect creates what many describe as a natural planetarium. Among Australia's most ancient geological wonders, Wave Rock stands frozen in time, like a petrified ocean swell about to crash onto a prehistoric shore. Located near the small town of Hayden in Western Australia, this 50 feet or 15-metre high, 361 feet or 110-metre long granite cliff face represents one of Earth's most captivating natural illusions. At an astonishing 2.7 billion years old, Wave Rock predates even the dinosaurs. This remarkable formation began taking shape through a multi-stage process spanning millions of years. The granite cliff constitutes part of a larger Inselberg, island mountain known as Hayden Rock. Its distinctive wave shape emerged primarily through chemical weathering beneath the ground. Groundwater concentrated around the base of the rock gradually dissolved minerals in the granite, creating a concave pocket. Consequently, as the surrounding land eroded away, this undercut section was exposed, revealing the wave-like overhang we see today. The striking colour palette adorning Wave Rock's surface tells its own geological story. As rainwater runs down the cliff face, it dissolves and redeposits chemicals present in the granite. This process creates the distinctive vertical stripes in various hues. For thousands of years, Aboriginal peoples have held this site sacred. Known as Kata Kitch in the Noongar language, Wave Rock features prominently in indigenous Dreamtime stories. According to Baladong traditions, the formation was created by the rainbow serpent, who, after consuming all water in the land, dragged her swollen body across the terrain, leaving this distinctive imprint. In the barren expanse of Turkmenistan's Karakum Desert lies a fiery anomaly that differs from other weird rock formations, the door to hell. This blazing crater, officially named the Darvaza gas crater, has been continuously burning for over 5 decades, creating an otherworldly spectacle that draws adventurous tourists to its fiery rim. The precise history of this flaming pit remains shrouded in mystery, with conflicting accounts of its creation. The most widespread explanation suggests that Soviet geologists accidentally created the crater in 1971 while drilling for oil. After hitting a natural gas pocket, the ground beneath their equipment collapsed, forming a large hole approximately 230 feet or 70 meters wide and 99 feet or 30 meters deep. Scientists deliberately ignited the escaping methane to prevent poisonous gases from spreading to nearby communities or killing desert wildlife. They anticipated the gas would burn out within weeks, yet 50 years later, the flames continue. In 2013, Canadian explorer George Kourounis became the first person to reach the bottom of the burning pit. Wearing an aluminized suit with a Kevlar harness and specialized breathing equipment, he collected soil samples that revealed something extraordinary: extremophile bacteria thriving in this seemingly inhospitable environment. These heat-adapted microorganisms were not present in surrounding soil samples, suggesting they evolved specifically for this extreme habitat. Scientists believe these findings may help understand how life might exist on methane-rich exoplanets with similar harsh conditions. Nestled in the Coyote Buttes area near the Arizona-Utah border, the wave stands as one of America's most photographed geological oddities. This mesmerizing formation of undulating sandstone appears like a frozen ocean wave, complete with swirling patterns that make it a photographer's dream and a scientist's puzzle. The genesis of this sandstone marvel dates back approximately 190 million years to the Jurassic period, when the region resembled a vast, windswept desert similar to today's Sahara. Initially, the formation began as enormous sand dunes that compacted and solidified into Navajo sandstone over millennia. The wave consists primarily of 2 intersecting U-shaped troughs, one measuring 62 feet or 19 meters wide by 118 feet or 36 meters long, and another spanning 6 feet or 2 meters wide by 52 feet or 16 meters long. Water played the first role in sculpting these troughs. Infrequent runoff initially carved paths along joints in the sandstone. As time passed, the drainage basin feeding water to these troughs gradually diminished, making water erosion less significant. Subsequently, wind took over as the primary sculptor, with blowing sand continuing to polish and refine the formation. This ongoing erosion accentuates the cross-bedding patterns that record ancient wind directions from the Jurassic era. The vibrant color palette decorating the wave results from mineral deposits interacting with the porous sandstone. These colors arrange themselves in rhythmic alternating bands representing periodic changes in prevailing winds as ancient sand dunes migrated across the prehistoric desert. Complex interactions between iron-enriched fluids and groundwater created this striking palette, either concentrating or removing iron oxide grain coatings within the sandstone. To preserve this geological wonder, authorities strictly limit access to 64 visitors daily, with demand far exceeding availability. Rising dramatically above Norway's stunning Lysefjord, Pulpit Rock stands as one of nature's most unusual sculptural achievements. This flat-topped cliff formation towers 1,982 feet or 604 meters above the crystalline waters below, creating a near-perfect natural viewing platform. The creation of this remarkable formation began approximately 10,000 years ago during the last ice age. As massive glaciers moved across the Norwegian landscape, they exerted tremendous pressure on the terrain below. The process began when the edges of ancient glaciers reached the cliff area, causing water to freeze in mountain crevices. This freezing action broke off large angular blocks of rock that were subsequently carried away by the retreating ice masses. Unlike many rounded formations shaped by continuous erosion, Pulpit rock maintains its distinctive angular appearance due to differential weathering. The plateau consists primarily of tough granite, gneiss and migmatite materials, significantly more resistant to erosion than surrounding rock layers. This selective erosion process created the almost mathematically precise 82 by 82 feet or 25 by 25 meter square platform that draws visitors today. The nearly perfect square plateau provides an unobstructed vantage point described as one of the world's most spectacular viewing points. This geological marvel has become one of Norway's most popular outdoor destinations, drawing more than 300,000 visitors annually. In China's Hunan province, thousands of natural stone pillars thrust dramatically skyward, creating the otherworldly landscape of Tianzi Mountains. These quartzite sandstone spires stand among Earth's most peculiar weird rock formations, often vanishing into clouds that transform them into floating islands. The Tianzi Mountains began forming approximately 400 million years ago through a remarkable geological process. Originally sedimentary rocks beneath a vast ocean, these formations emerged through irregular rising patterns of Earth's crust. Subsequently, around 318 million years of persistent erosion sculpted these distinctive, tall, slender mountains. The area now contains more than 3,000 quartzite sandstone pillars and peaks. What makes these formations scientifically fascinating is their composition. The mountains primarily consist of quartz sandstone, except for a layer of limestone and minimal tortoise-patterned stone at the summit. This unique geology creates distinctly stratified layers with different coloration and shapes developed through exposure to the elements. Water erosion carved along vertical joints in the rock, while gravity collapse further shaped these remarkable structures. Tianzi's microclimate transforms these stone pillars throughout the year. The area experiences approximately 240 frost-free days annually, with average temperatures of 53 degrees Fahrenheit or 12 degrees Celsius, and substantial rainfall reaching 1,800 millimeters yearly. This creates ideal conditions for the region's most distinctive phenomenon, thick mist that regularly envelops the mountains. This fog occurs over 200 days annually, creating what locals call the Sea of Clouds. As wind drives the white mist between peaks, it reveals glimpses of stone pillars seemingly floating in air. Visitors experience a constantly changing panorama as mountains appear and disappear within minutes. Stretching across 1,162 square miles or 3,010 square kilometers near the Farafra oasis in Egypt's western desert, the White Desert presents an otherworldly landscape that appears like freshly fallen snow in the middle of the Sahara. This national park, officially designated as a protected area in 2002, showcases some of Earth's most bizarre weird rock formations. The geological history of the White Desert began approximately 100 million years ago during the Cretaceous period, when this entire region lay submerged beneath an ancient sea. Over millennia, layers of marine sediment accumulated, primarily composed of calcium carbonate from the remains of countless marine microorganisms. These sedimentary layers eventually formed the bedrock of limestone and chalk that characterizes the area today. Examining the rock formations closely reveals fascinating evidence of this marine past. Scattered throughout are fossilized seashells, mollusks, crustaceans, and even prehistoric shark teeth embedded within the limestone layers. Fundamentally, what makes these formations extraordinary is the persistent sculpting action of wind and sand over millions of years. Through a process known as ventifacting, sand particles carried by powerful desert winds act as natural sand-blasting agents, gradually carving the soft chalk and limestone into fantastical shapes. This relentless erosion has created columnar geological features that resemble giant mushrooms, often called desert ice by locals. The distinctive white color that gives this desert its name comes from its high concentration of chalk and limestone, both rich in calcium carbonate.